Okay, so welcome to the November San Francisco Bay Area Postgres Users Group meeting. We're happy to have you all here. As noted, this meeting is being recorded. If you turn on your camera, your image will be captured. If you ask a question and you turn on your microphone to do so, your voice will be captured as well. If you want to ask a question and don't want your voice in the recording, then you can put your question in the chat to the meeting organizers, and we will convey it to the speaker. We will post the recording on YouTube after. We're not recording it just for fun. There is a purpose. We want to be able to share it with everybody who couldn't make it today. We'll do Q&A at the presentation. If you choose to ask a question, again, if you turn on your mic, you will be part of the recording. You can also use the raise hand function, and we can call on you that way. If you're using an older version of the app and you don't have the raise hand function, drop a message in the chat and the organizers will add you to the Q&A queue. Q&A queue. Question and answer queue. Lots of Q's happening there. So if you have any technical issues, please send a message to the organizers during the meeting and we'll deal with it. If you drop out and are unable to rejoin, post a message on the meetup board. We are watching that and monitoring it during the meeting. But hopefully you won't have any issues and it will all be fine. The San Francisco Bay Area Postgres Users Group is sponsored by Postgres US, aka the United States PostgreSQL Association, for financial support, meetup fees, and other support. We thank them for their support. As a disclaimer, I'm also president of PGUS, but these two things are not related. We also have a video sponsor, which is PGX. And again, disclaimer, I work at PGX. But PGX manages and pays for all the video recording, editing, and managing the YouTube channel. So without further ado, I'm going to introduce today's speaker, Christophe Pettus, is here to tell us about what's new in Postgres 16. And Christophe, I'm going to make you the presenter.
Hey.
Oh, you are the presenter, and I'm going to turn off my camera, so the show is all yours now.
Let's see. Okay, just taking a moment to get my, I wonder what's going on here. It's giving me trouble sharing the slides. Give me just a moment and we will see about that.
Technology is so awesome when it works, and then it does things like this.
And then it doesn't, yeah. And we'll just see about doing share the entire screen. There's that. And we'll, I think, can you still see the slides?
Yes.
Great. Okay, yay. So hi, I'm Christophe there. Thank you for your patience as we deal with technology. Hi, I'm Christophe Pettus. I'm the CEO of PGX, and we are going to have a fun, short, but hopefully interesting excursion into what's new in Postgres 16. Brand new version. It's the most recent major version of Postgres. It was released on September 14th of this year. Please download it and test it. Even if you don't slam it into production right now, test it, see how it works, have fun with it. It's especially important to test on large data sets, since really that's something that can only happen out in the field. The continuous, we don't have a 1 terabyte test set for continuous integration. So feedback from users about the behavior of the latest version is really super important. And we're just going to talk about some highlights here. There's lots and lots and lots of stuff in every Postgres major release. So consult the release notes for details. And we'll cover some these 4 areas. Enhancements to SQL, performance enhancements, system administration stuff, and lastly, logical replication changes. Okay. The first thing we're going to talk about is improvements to SQL. I'm going to start with one that's kind of near and dear to my heart, which is there's a new aggregate function, any value. It's in the SQL standard. Postgres 16 now implements it. It handles a very annoying problem. So let's take a look at this. This is a really simple query. You have a customers table. and an orders table, and you join on them, and you want to get the total orders for every customer. So you do the obvious thing. You join on the customer ID, you group by the customer ID, but you also want the name of the customer, right? Let's be handy. But it doesn't let you, because since you're doing an aggregation, you have to aggregate on every field that you have to either do an aggregation or an aggregate function on all the fields. But what does it mean to aggregate on name? The name and the customer ID are presumably completely correlated. So people could do all sorts of things. They use min there or something like that, just to slap in anything. So any value is kind of a cleaner way of handling that. Any value means just what it says in, when you're doing a aggregation. It can pick any of the candidate values. It doesn't add them or take the lowest. It just grabs one. But in the case of a perfect correlation, that's fine. So it's nice to have just a official way of handling that problem. SQL will now allow, Postgres will now allow now decimal literals. It's kind of interesting that it took it this long. So you can write hex literals, octals, bits, and you can also put underscores, which is if you have large numbers that you want to break up and make a little more human readable. The SQL standard has standard JSON constructors, for example, creating a JSON array or an object out of the results of a query. Up till now, Postgres has those functions, but Postgres has its own unique versions. So now Postgres implements the SQL standard ones, which if you are trying to, this is handy as if you're porting from another database product, or you just like doing things in the SQL standard way. All the Postgres specific functions, of course, are still supported. Postgres also now adds some standard JSON predicates. For example, you can ask if something is a JSON array or a JSON object or a JSON scalar. So, and these predicates work just like any other, is null or any other predicate. If you're writing, this is specifically very useful if you're writing PGSQL. Postgres has always had a variable, accessible setting, current user, which is, as it implies, the current user that's logged into the database. However, it can change in the course of a session as if you assume a new role, which of course you can. So the system user is the one that was actually used to connect to the database. It shows the user and also the method that was used to connect to the database, and it can't change during a session. Once you've logged in, that will be constant. This can be useful if you're doing identity checks or something like that of who the current user is, or if you're using role level security and want to base something on the actual login user rather than any assumed role. Okay, those are the highlights of SQL changes. There are a bunch of others, but those are the ones that really stood out, I think, as being interesting in this version. And now let's talk about performance enhancements. Lots of under the hood changes. There are lots of invisible improvements. They're not tied to a specific feature. You just get them as part of using Postgres. There's faster memory management. There's explicit SIMD support. That's like the Intel SoC2 or the ARM Neon extensions. So that will improve things, especially on high core count machines. So relation extension is faster. The relation extension occurs when you fill up one of the underlying file that constitutes a table or files. Tables are broken into multiple 1 gigabyte segments. You run out of space at the end, it adds more. Postgres' previous algorithm for this was kind of conservative and didn't really add a lot of space to the end of each table when it needed it. The result is in very high insert rate situations, relation extension, the process of adding that space, could actually be a significant bottleneck. And you will see this in like PG locks. It'll say it's waiting on an extend lock. The newer algorithm is more generous, adds more space, and will significantly improve in performance in high insert rate situations because it just won't have to wait on those locks for so long. It's a bigger deal than it sounds. as the trend over the last, I don't know, 6+ versions of Postgres is that more things are now able to be done in parallel. One of the additions in Postgres 16 is string aggregation. The string ag function and the array ag function can now be done in parallel. Hash write and full joins previously could not be parallelized, and now they can be. Oops. And hang on, skipped over that too fast. And so if you're not giving Postgres enough parallel workers, this might be a good time to start, because a lot of cool stuff can now be parallelized. There's a lot of improvements in query plan, specifically around the use of the distinct operation. It now, traditionally, Postgres would build the complete result set and then pass it through a unique planner node, a unique filter, to execute a distinct. Now, if it can, it'll use a limited and index scan instead, since indexes kind of do uniqueness automatically by the fact that they compress keys down. And this can be significant performance improvements. A lot of improvements around group by and distinct in version 16. Release notes go into detail about that. Okay, and now a little bit about systems administration. There are improvements to pghba.conf and also pgident. pghba.conf is the file that controls who can connect to the database and what kind of credentials they need to use to do it. One of the things that can be in the pgha.conf is limiting who can connect by IP address, by network address. And in addition, now we can use regexes. So for example, if you have a stylized naming scheme for users or databases, and you want to match, in this case, it matches every username that begins with dev and every database name that begins with dev. And this allows anything from CIDR 10/24, and it requires that they use the Scram SSH2 password algorithm, which is the new standard password algorithm in Postgres. So this can be handy, especially in large environments where you have you want to create a lot of users, but they all begin with dev dash name, or you have dev or dev databases. So just handy little functionality. The previously you had to just have one giant file for pghba.conf. Now pghba.conf can use kind of the standard Linux include if exists, or include dir operation. So you can include a file if it exists, or include all the files in a specific directory. So it's much more manageable, like you would expect a standard configuration file to be. So libpq is the standard C library for that is included with the PostgreSQL distribution. It's what clients link to in order to talk to Postgres using the standard Postgres protocol. It's not required. You can write your own client driver, your own client library, and many languages do, but most of them are based on libpq down under the hood. Previously, this has been around for a while, is you could give a list of hosts to libpq, and it would connect to the first one that actually worked. So it could walk down the list. And this was called load balancing, but it wasn't really very good at load balancing, because it would always connect to the first one. So if the first one was up, it would get all the connections. Now, that was the old behavior. Just tried each one in order. Kind of boring. The new behavior, which is now available optionally, it's not required, is it'll pick one at random from that list, which does a little better in terms of load balancing. So this is not super sophisticated load balancing. It's not like it measures the number of connections that are open or anything like that, but it's kind of a quick, cheap, and cheerful way of doing load balancing. It's pretty nice. Some improvements to vacuum, everyone's not favorite feature of Postgres. During vacuum freeze operations, there's more data reported, like how much freezing actually occurred and things like that. Vacuum freeze is also significantly more efficient. It can freeze entire pages at once, and it will also do opportunistic freezing. So for those who are not familiar, vacuum freeze, which usually manifests itself as a line in pgstat activity called auto vacuum paren to prevent XID wraparound close paren, is an operation that has to be performed periodically to mark tuples such that they're what I like to say is they're permanent parts of the database. That doesn't mean they can't be deleted, but it means that no transaction can roll back and cause them to vanish. This is important because Postgres' transaction ID are only 32 bits. So if you didn't do a freeze operation, eventually you'd run out of space in that 32 bits as more transactions happen. And 2 billion transactions, or 2 or 4 billion transactions, is not that many transactions in the modern world. So they have to be frozen so that you kind of reclaim space out of that transaction ID range is one way of thinking about it. But it's a surprising operation because it doesn't tend to happen initially. It tends to wait until the database has been running for a while and it needs to do it, and it can be a surprise. So anything that can reduce the surprise factor is useful. And this optimization will actually be quite helpful in that regard because it'll help freeze opportunistically as the system runs. You could also limit how much shared buffer vacuum and auto vacuum use. The issue here is that frequently auto vacuum and vacuum have to scan entire tables, which means they have to read the entire table into memory, which kind of destroys your caching in shared buffers because everything has to pass through shared buffers in order to be processed by Postgres. And if you're reading a 12 terabyte table and you have, say, 32 gigabytes of shared buffers, eventually everything's going to get evicted out of shared buffers. So this can be handy so that you tell vacuum only use 8 gigabytes of all that or 4 gigabytes and leave the rest to standard database operations. So yeah, so it prevents cache pollution and just too many page evictions due to vacuuming. Some additions to system stats. Postgres now keeps track of the last index and sequential scan of each relation. So for example, you can use this in addition to the number of sequential scans to see kind of has anything changed. This is very handy if you drop in a new index and you can see that sequential scans just aren't happening anymore. That's probably a victory for the index, or which can be very useful as opposed to just the raw count of how many have happened. There's a new there are new views that keep track of much more detailed I/O statistics for Postgres. So definitely look at those. If you have your own monitoring tools of some kind, check those out and see about adding them. I'm sure commercial monitoring tools will definitely start taking advantage of those. Okay, well, now we're going to talk about what kind of a hidden feature that it's not a big deal. They don't make a big deal about it in the release notes, but it's really huge. And that's why I saved it for last. So the first one, this is not that big feature yet. Logical replication, there's parallel apply. So applying is what happens on the subscription side as changes come in from logical replication. Now you can have parallel apply, which can significantly speed up logical replication. You can use multiple processes to receive data and apply it to the database from the same subscription. And you enable it on a per subscription basis, so you can divide the workers up easily. You can also now, and this is a pretty substantial feature, have a logical replication be a publisher, logical replication publisher be a binary replica. You do the create publication on the primary, but the subscriber can then connect to that replication of that publication, on a binary replica. Previously, you couldn't do that. Only a primary could be a source for logical replication. And that was, not great because you're adding more load to a primary. Now you can offload that logical replication load onto replicas, which is a very nice feature. It's still not quite fully failover safe. You still really can't use logical replication as a way of handling as a failover candidate the way you can with binary replication, but we're getting there, step in the right direction. Okay, now it's time for that big feature I was teasing you about, which is the logical replication origin. The origin of each change that's shipped over on logical replication is marked with an origin, which is what system created it. Now, the feature is you can filter what records you send to a subscriber based on the origin. Okay, that sounds pretty detailed and gritty and not that interesting. The origin is the system that initially created the row. What this avoids is ping-ponging. So the reason that right now you can't have bidirectional replication, where you have two systems which ship changes to each other from the same tables, is that there was no way to suppress the problem of you ship a change over to the subscriber picks it up, ships it back to the primary then picks it up and ships it back to the subscriber, and that happens forever until the system crashes. That's called ping ponging. You can now avoid ping ponging, which means that you can say only don't pick up any changes that I created. So the one system will ship over the change, and rather than send it back, it'll just get filtered out. And so only the changes that each system initiated get applied to the other. So this isn't quite full bidirectional multi-master replication, but it's an essential component for it. So we're getting to the point that you could start doing full multi-master replication inside of Postgres without having to have a separate product. You can make use of this now. It doesn't solve. There are problems that you still need to solve, like what happens on key conflicts. What happens if you have multiple versions of the same row that kind of get applied to each other simultaneously, and this doesn't solve all those problems. But if you keep your logical replication model simple enough, it could solve a lot of these problems, and it's a step in the right direction. It's very exciting because one of the most requested features in PostgreSQL is proper multi-master replication. And everyone says, well, MySQL has had it for years. Why can't Postgres do it? So we're finally starting to take steps to actually build that into core. So that's pretty neat. Okay, this was a breezy summary of the features. I hope you enjoyed it. Always read the fine print. There are hundreds of improvements and fixes and changes in every new version of Postgres. Always read the release notes. In some cases, it's because the behavior of functions has changed or there have been deprecated features. So take some time to read the release notes. There's the link to them for version 16. So, and there's lots and lots of other stuff. So thank you. And any questions? Or did I completely overwhelm you?
I don't see any raised hands. I don't see. There's one comment in chat. Useful for my database of people named Devin. So there's that. But questions, comments, anything, anybody?
Expand the acronym CFE. I see it in chat.
Just popped up.
No. TDE. Okay. There is ongoing work for doing total disk encryption, which is in the context of Postgres that the underlying files are encrypted with a key that Postgres manages, so that if you have access to the underlying storage, you see the encrypted one and can't decode it. There is ongoing work to do that. I would not expect it did not land at 16. I don't expect it to work at version 7, to land at version 17 either. There's just a lot going on there. One thing also to be aware of is TDE does handle a very limited threat model, which is unauthorized access to the underlying media, which is usually not the threat model you need to care about. The threat model you usually need to worry about is unauthorized access via the application, and TDE doesn't help you there. But that's a separate security talk, which JSON table. No, I don't actually know the state. I know that a lot of the SQL standard stuff was landed in 16 and then was reverted because of bugs. So keep your fingers crossed for 17. Anything else? Okay, then thank you very much.
Great. Thank you, Christophe. Appreciate your time. Thank you, everybody, for attending. And hopefully that was useful and informative and perhaps even entertaining. And several comments in the chat saying thank you. So good job, Christophe. Thank you. And let's see. So going forward, let's see. We are not doing a PUG in December between the end of the year, everybody trying to make their deadlines and this and that. And that's also the week of Postgres Conference EU in Prague. So that would be a little bit of a challenge. But hopefully we'll see you at PGEU in Prague. If not, the January PUG will be January 10, 2024. I don't know about you. I'm not ready for dates that end in 2024 yet, but there we are. We have dates in 2024. So January 10, speaker TBD. We have a couple of interesting possibilities. We're just trying to work out time zone issues and things. Again, next conference is coming up, Postgres Europe, December 12 to 15 in Prague. And you heard it here first, soon to be announced. PG Day Chicago will be April 26, 2024 in Chicago. What a surprise. Those are the next two big things coming up. There's FOSDEM if you want to go to Brussels in February. So those are the next things coming up. PG Day, Nordic PG Day is March 12, and then PG Day Paris is March 14, 15. So lots of things happening in the first quarter of 2024. And PGCon, yes. For PGCon Ottawa is now Postgres Developers Conference, and it will be in Toronto, and the dates are May something, May 28 to 30. So that was just announced, and you should see something in your email if you're on the Postgres Announce email list. If you're not, now you heard it. So there we go. So lots of upcoming interesting things. Call for papers open, and sponsorships and all kinds of fun things. So put in your talks. And speaking of talks, we're always looking for speakers. So if you're interested in presenting at ASF Pug, drop us a note either via Meetup or through our social media, and let us know, and we'll get you on the schedule. It'd be great. And let's see, last but not least, when the video is ready, it'll be posted on YouTube. We'll send the link by email. We'll post it on Meetup, and also watch for it on our social media. Again, thank you, Christophe, for speaking. Thank you, PGUS and PGX for sponsoring. Thank you all for attending, and we'll see you, if not at a conference soon, we'll see you in January. Bye-bye.